The only difference between these two problems and the ones below it and the ones you just did are this number in front of the x. So, or excuse me, in front of the x squared. So the only thing that changes is actually just the factoring process, right? If I just go ahead and start with the y-intercept, it's literally exactly the same thing is going to happen, right? Which is this is going to equal 0, this is going to equal 0. The y-intercept is 3, that's 0, 3, right? Literally, like, absolutely nothing changed here. I can show you the same thing is going to happen here. I want you to see that you've already done this. There's just one piece that's going to feel new, but the thing is you've already factored. Right? Okay, so there we go. There's the y-intercepts. Now, here, we've already factored things like this. So are they harder to factor? Oh yeah, they're a little bit harder, but this is not new, right? You know how to factor this. This still equals 0. We're still factoring, right? Remember, I need this times this to equal this, and this times this to equal this. We can do this. So 2x times x, that's 2x squared. Now this is either 3 and 1 or 3 and 1, like that. So let's just start with 1 and see what we get. So let's say I chose 1 here and 3 here. So that's 2x, that's 6x plus 1x, that's 7x. Oh, nope, I want it to be 5x. So that doesn't work. Let me go ahead and switch them. So 2x times 1, that's 2x plus 3x. That equals 5x. Perfect. That's what I want. Okay. Looks good. So now I know either this number equals 0 or this number equals 0, because when I multiply them together, they equal 0. So one of them must be equal to 0. Okay. So here I'm subtracting 3 from both sides. Look, this is a little bit different because this is actually a two-step equation, right? When I divide by 2 here, I'm going to get x equals, you're going to just use a calculator if you're not comfortable with this, that's fine. Negative 3 divided by 2 is 1.5, negative 1.5. So my first x-intercept is negative 1.5 comma 0. This x-intercept is just negative 1, so that's negative 1 comma 0. So man, these two x-intercepts are actually pretty close to each other, right? Look, this is negative 1, 0, that's right here, and negative 1.50 is right here. Why are they so close? The reason they're so close is because, look, this parabola comes down and just barely dips below the line. That's why they're so close, right? That's what a parabola looks like when these two x-intercepts are so close. The reason is either because it's super skinny, which we know it's not because we can see where the y-intercept is, or because it's just kind of turning almost at that point. Okay, so there's one example. Let's set up this next one. Once again, we're going to factor. I know that these two have to multiply to be 5x squared, so that's going to be 5x and x. And then to multiply to be negative 2, I know I need to have one positive, one negative. I'm just going to put the positive here and the negative here for a moment, and we'll just see what happens next. I have a 2 here, so that can only be 2 times 1. So let's say I put 2 here and 1 here. Multiply, I get 5x times negative 1, that's negative 5x, plus 2x. That's negative 3x. I want it to be positive 3x, so I realize, oh, okay, the numbers are good, right? But I want this to be positive 5 and negative 2. So I'm going to switch the signs. I'm going to make this negative and this positive. Right? Then when I multiply, this will be positive 5x minus 2x, and that'll be positive 3. So perfect. My factoring step is done, and I can go on to solving. Either this equals 0 or this equals 0. Hey, look, this is the same one as here. So this is x equals negative 1. That's negative 1, 0. Put that right here. Okay, then this one, when I add 2 to both sides, and I divide by 5, okay. Again, if you're not comfortable with this, put in your calculator. It's positive divided by positive, so it's positive. And this actually becomes 0.4. 2 divided by 5, 0.4. So that's like pretty close, right? This is negative 1 here. 0.4 is right here. And we can see, right, this is actually a parabola that just, it kind of turns right here by the origin. We can see it's going to look something like that, okay? So notice the differences here. The factoring is that little bit trickier, factoring with the number out in front. And what happens is that when we have a number that's not 1 right here, what ends up happening is we sometimes get a decimal. But that's okay. We just eyeball it, right? Like this is between negative 1 and negative 2. This is between 0 and 1, okay? The decimals are no problem. For right now, we're just kind of placing it approximately on the graph so we can get an idea of what it looks like.